Hello and welcome back. Today we are going to be starting a brand new chapter with starting absolute value functions. So today we're going to focus on equations, and then on another day we're going to deal with inequalities. So I'm going to be doing some of these questions, but not all of these because these are kind of taken directly from your assignment, and whatever ones I don't do, that's going to be what you end up doing. Okay? So for all absolute value equations, you are going to need to set up two, and I repeat two, equations. You start by the obvious after the absolute value bars are isolated, which these are, they're by themselves. Then you can do 3x is equal to 9 and 3x is equal to negative 9. So you change what's they're equal to, not what's on the inside, even though that's kind of the opposite of what an absolute value function does. And then you just solve them both. Divide by 3, x is equal to 3, and x is equal to negative 3 if I divide it by 3 here. And we get two answers. For the majority of these, you are going to get two answers, so that is normal. All right? It's as easy as that, everybody. So when you're doing this, it is highly recommended that you plug your answer back in to make sure it actually is true. If you plug in 3 times 3, the absolute value of 9 is still 9, so it works. 3 times negative 3 is negative 9, but the absolute value of negative 9, absolute values always make something positive, so it still ends up equaling what it should be, okay? So as we get to more advanced problems, it is more and more and more suggest that you actually plug the answer back in, all right? Number 2, absolute value bars are by themselves, so it's the same exact thing. We just set negative 3 are equal to 9 and negative 3 are equal to negative 9. And you divide, and you get r equals negative 3. And you divide, and you got r equals 3. Both of those, when you plug them back in, will still work. It doesn't matter the fact that that was negative in the inside, because when you plug it back in, you get 9 equal 9, and negative 9 for the absolute value would equal 9 as well. All right? So let's actually go and look at something that's a little more serious. Well, 5's not that much more serious, but I do want to show you how to do that one. Because a lot of people might be panicking. What do I do with the divide by 5 or divide by 3? You just multiply. When you set both of them equal to their respective parts, one being 2 and one being negative 2, you multiply by 3 on both sides and you get n equals 6. When you multiply by 3, it cancels that. And when you multiply by 3, it cancels and becomes your negative 6. Okay, so that one wasn't that complicated either, believe it or not. But once you get to problems like number 6, you might start to think that's different. And again, as long as these bars are by themselves, you can set them both equal to, x, a positive and a negative version. So I had negative 4 plus 5x equals 16. And negative 4 plus 5x equals negative 16. I struggled on that one. Oh, that was sloppy. Sorry. And then I solve like a normal equation. I'm going to add 4 and add 4. And I get 5x is equal to 20. And I divide by 5 and I get 4. And over here I would have to add 4 and add 4, which won't equal 20. But it does equal a number. It's negative 12. It's negative 16 plus 4 is negative 12. And we divide, and we get x is equal to negative 2.4. So we get an answer both times. Not a big deal. Okay? And I would highly recommend plugging those in. I would see if it worked. Now, plugging in negative 2.4 would be a pain in the tuchus, but it would still work. When you plug it in, you'd get negative 4 plus 5 times negative 2.4, which ends up being negative 4 minus 12. Is the absolute value of negative 16 equal to regular 16? Yes, it is. So the majority of these problems, you're going to be okay when you plug the answer back in, but there's going to be a few that won't work out, and you need to be aware of that. All right? Number 10. First problem where the absolute value bars are not by themselves. If they're not by themselves, what you end up having to do is add 5 to both sides. You get v plus 8 equals 7. And then, once the absolute value bars are by themselves, then then, ladies and gentlemen, you can do v plus 8 equals 7 and v plus 8 equals negative 7. It is not until after the absolute value bars are by themselves with something in the inside that you can do that. You solve both, subtract 8, v would equal negative 1, and subtract 8, v would equal negative 15. All right. Moving right along to the back side of this page, let's encounter something that's a little bit more difficult. Let's say we have, let's just do 13. 13 looks a little harder. Here we have a 5 that we have to move over. So I'm going to do that first. I'm going to subtract 5 from both sides. And I get negative 8 equals negative 2n equals negative 80. I cannot take the bars and be like, get rid of them right now because they're not by themselves. That negative 8 is multiplied with the absolute value, and you cannot multiply them. You cannot, I repeat, you cannot distribute that number. So over here, like on this one, I cannot distribute the 5. I'm not allowed to do that. You are not allowed to do that. You are forced and have to divide it off. Divide by negative 8 to get rid of 8, and divide by negative 8 on the other side. Now we have the absolute value bars by themselves, and negative 80 divided by negative 8 is 10. Okay? From here, negative 2n would equal 10, because the absolute value bars are by themselves, and negative 2n would equal negative 10. Set 1 equal to positive, set 1 equal to negative, and go from there. Divide by negative 2. N would equal negative 5. Divide by negative 2. N would equal positive 5. Easy as that. Easy as that. Let's see, which one? Now 15, I don't want to do the whole problem, but how do we get rid of that 8? How do we get rid of that 8 on 15? You multiply it to get rid of it, of course. And you get 7p plus 4 is equal to 24. And because the absolute value bars would be kind of isolated at that point, it would be 7p plus 4 equals negative 24 as well. And you would solve both. You could solve both of those. All right. 16 I do want to do because I'm wondering what you think we would need to do with that negative sign here. And that negative sign is the same as a negative 1. All right, so don't panic. Don't panic, all right? We're going to subtract 3 from both sides, get negative 1, 8x minus 6, absolute value, equals 0, which already feels funky. But that's okay. Because you can divide by negative 1, and 0 divided by anything is 0. You may not be able to divide by 0, but you can divide 0 by any number. Because if you have no pizza and 30 friends, nobody's eating. It's 0. Add 6, 8x equals, oh, whoa, wait a minute, I forgot. That's technically an absolute value, right? Do I have to do the equals negative 0 this time? Not really. The absolute value is isolated. We can drop the absolute value sign, but we don't need a 0 and a negative 0. We can just add 6 and divide by 8 to get 6 over 8, which of course is 3 over 4 or 0.75. All three of those are technically correct answers. But do make sure that whenever you are dropping those absolute values that you do one positive and one negative. Okay? And let's do one more for today. Let's see, which one do we want to do? I want to do number 18. It's right there. I was debating it for a while. You saw that pause. Add 9. 6, absolute value, 1 minus 5x equals 56. Divide by 6. 56 divided by 6 is a number. I'm hoping it works out. Wait, 56 divided by 6. It's been a long day. It doesn't work out. I was worried. I thought it would. That's because that's not 56. Isn't this 58? And, oh my goodness. Oh, it has definitely been a long day. What's 57 plus 9? 57 plus 9 is 66. That's completely different. I'm like, why is this not working out? Because my brain is mush, apparently. 1 minus 5x is equal to 11. 66 divided by 6 is 11. And now because we have the absolute values, we can do 1 positive, and 1 minus 5x equals 11, and 1 minus 5x equals negative 11. Subtract the 1, subtract the 1. Negative 5x equals negative, not negative, positive 10. So that means x would equal negative 2. Subtract the 1, subtract the 1. Negative 5x would equal negative 12. And then divide by negative 5, and you get positive 2.4. Now, I do have to show you where you really, really need to make sure that you are checking your answers. I'm going to give you an example like that. This is a separate example. I believe that there is a second video where it shows you a little bit more intricacy on these negative values and making sure you're plugging it back in. So bear with me right now. This is an extra problem, but it is a very important extra problem. Let's say that we had something like simple absolute value of x plus 4 equals negative 5. All right? It seems simple. It seems easy. Absolute value bars are already by themselves. We're going to end up with x plus 4 equaling negative 5 and x plus 4 equaling positive 5. Subtract the 4, subtract the 4. X would equal negative 9, and x would equal 1 when we subtract 4 here. Here's the issue. Both of those are wrong. Both of them. If I plug that back in, if I plug in 1, let's say, for instance, 1 plus 4 is 5. The absolute value of 5 does not equal negative 5. So that doesn't work. Uh-oh. And then if I plug in the negative 9 plus 4 is 5. Negative 9 plus 4 is negative 5. But the absolute value of negative 5 is positive 5, and it's supposed to equal negative 5. So that also doesn't work. You need to plug in your answers. I'm going to do that one again. Negative 9 plus 4 should equal negative 5, but the absolute value of negative 5 doesn't equal negative 5. And because it doesn't equal negative 5, that one also fails. So this one, even though it looks so simple, is actually a no solution. Okay? Over the next few days, we're going to have to encounter that idea that these problems can have no answers or have fake answers. And the way that you need to recognize it is, first off, highly recommend plugging in all your answers. Second off, if you ever encounter a problem where it's like absolute value equals a negative number right off the bat, that's impossible. Because no matter what, when you take the absolute value, it spits out a positive number by just definition of absolute values. So you need to check your answers, bottom line. Check your answers. We're going to have a few days where it's going to get more complicated, and you might think, oh, I'm never going to have to check my answers, but you do. You really need to be plugging in those answers until you are very, very confident with what's going on. Okay? So that's going to do it for this one. There is a bonus video available if you want to watch it. It's 10-ish minutes long. Highly recommend you do it. That's also available on Schoology. Till then, I will see everybody later. Bye.